Any question related to only your personal situation, just you can talk to me after the class, okay? All right, guys. So the density lab is the idea of density. I think most of you familiar. So the density is mass or volume in general, right? So the density, the symbols we use is actually this sign is actually rho, RHO, rho. This is a Greek letter, okay? So which is equal mass or volume. Generally, I think you guys are familiar now with SI units, right? So the mass must be measured in kilogram in generally. If I want to use SI unit, volume should be meter per cube. But in this experiment, instead of kilogram, we will be using gram. Instead of cubic meters, we will be using centimeter cube. Okay, the reason why we do that in the measurement instrument, those are the direct units given in the measurement instrument. Because of that, we will be using the same. And also in at the end of the experiment, we will compare those numbers to the standard values of three different materials. So those values in this table are given in the same unit, okay? Because of that, we will keep the same unit. So the density is measured at the end gram per cubic centimeters, okay? That's the plan. And in terms of measuring, now the idea of density is technically if you have any object, how the object is made on, what material the object is made on, is actually the why the density is important, right? Because the size or shape of the object doesn't matter. Whatever the material it made of has to have the same density, whether it is smaller, larger, doesn't matter how the three-dimensional or two-dimensional, what the object is. If the object is made on copper, then any object made on copper has to have the same density, right? So that's why that the physical parameter density is the very important parameter in physics and chemistry, particularly. Okay. So
Wait, can you
now
repeat that, Professor?
the idea of the density is doesn't matter what the object is. Let's say you have an object. Let's say, for example, if you have a water, right? So let's say I have a larger water container and a very small amount of water right here. Now you can see mass and volume of these two objects are very different, right? So this is
Right.
going to be V prime, M prime. But if you take the ratio V prime to M prime and V to M, the density of the water going to be same everywhere. Make sense? That's
Oh,
the
okay.
idea. That's why the parameter density is actually itself very useful for many different situations. The reason that tells what that material is, okay? That's the intrinsic property of the material, not the intrinsic property, okay?
Right. Okay. Thank
So, yeah, okay. So any other question? Okay, so which means now if I want to measure the density, so what you need, let's consider I have object, any like random object like this one, three-dimensional, some stone, something like that. If I want to measure the density of this object, I want to measure the mass of the object and the volume of the object. Mass can be easily done by using the scale, right? So in this experiment, we're going to use the spring balance. If you scroll down to the page number 3, then you will get a simulator link on the very top of the page, a web address. Just click on that. That should open up our simulator for the mass measurement of this experiment. That should be look like this picture. That has a different, like 5 different object on the bottom. We can select. And in the middle, you can see a stand, and then there's a spring.
Yeah, I see it.
Yeah. Now, this is a spring balance, right? You can hang the object right here. Whatever it goes down, you can read the scalar reading. That's the mass of the object, okay? And on that spring balance, you can see two different units on the left-hand side and the right-hand side. So the spring balance has a scale here, like a red arrow, And then left-hand side is the gram scale, right-hand side is the Newton scale. Newton scale we not going to use. Newton scale directly measure what we generally call the force of gravity. You will talk about that in your lecture class, hopefully this week or next week, probably, I think. But we need in this experiment only mass of the object, not the force of gravity. We need in terms of gram, okay? Because of that, we're going to read left side scale. And whenever we hang the object on this scale, zoom in picture will appear. You can easily read the scalar reading, okay? That's the plan. So the measuring mass is very simple. All we need to do is click any object on this list. Then the object go and hang on that balance. As soon as it hang in the balance, then you can see the zoom in picture appear. And then all we need is actually read this scale reading. That's it. Where the arrow, red arrow in our left-hand side scale. Okay, we interested only left-hand side scale. That's our gram. So the one other thing, when if you take a look, this scale carefully, it goes like 20, 0, 25, 50, and then so on, which mean in between 0 and 25, it's about like another 4 small lines. Each of those small segment is about like 5 grams. Okay?
Oh,
5
okay.
gram, right?
Yeah.
Yeah. So which mean we can measure down to 5 gram in this scale very easily. Okay. And that's how we're going to measure mass. First, we'll measure the mass of the selected object, which is asking in our table. And then the same simulator has how to measure the volume. Let's talk about volume in the bit. Let's finish the mass measurement first, okay? Any question? Okay, then if you go into the simulator, if you go into the data table, you can type the date, and your name, experiment number, and the class section, and then we'll start working on the table one. Okay.
Professor?
Yeah.
What does Newton mean?
Newton is actually the unit for the force of gravity. That's the Newton's second law. You will talk about that in your class. I think Newton, there are 3 Newton laws. In Newton's second law, what it tells you, if you have any mass object around the Earth's surface, this mass object will experience downward direction acceleration, always what we call the gravitation. This is not gram, okay? This is the gravitational acceleration. The symbol for that also generally we use G. That is the number 9.81 meter per second square. Every object dragging towards the Earth with that number. Okay. Now, if you have a mass m around the Earth's surface, if you multiply the mass by the gravitational acceleration, then you can find the force of gravity, Fg, which is mass times the gravity acting around the Earth's surface. This is actually what we call the force of gravity. Force of gravity is the generally one we actually feel. You feel like you tightly bound to the surface, right? You're not going to float around when you're walking around, right? That's the idea, because that force of gravity is tightly bound you into the Earth's surface, okay? That's the idea of the force of gravity. So the force of gravity is measured, the unit of kilogram for the mass, and the meter per second square for the gravitational acceleration. So this whole unit we'll write it as a Newton. So that is actually honoring to the person who actually first explained the Newton laws, okay? So that's why the unit of Newton we don't need for this experiment, because we interested only this guy, the mass guy, right? So that's why we're going to use the gram. Good?
All right, thank you, Professor.
Yep. Any other question? Okay, then let's measure this first, the mass of the 3 objects. We will calculate the density in this experiment. The lock, stone, and the cylinder. There's 5 objects here. We can do all, but it's not really anything meaningful. We're going to repeat the same calculation. Let's do lock, stone, and the cylinder, okay? So lock is the one, the padlock. I already clicked that. So all you have to do, sorry, let's see. Okay. So all you have to do, if you click on any of these objects, that particular object go and hang on the balance, right? So click on the padlock. Now that is hanging. Let's read that mass on our scale. We need left-hand side scale, right? In the gram. And this should be between 200, 205, 10, 50,
220?
220, yeah. The closest one, okay? So let's read it to
Yeah.
220. I think that's good, yeah. And it's that simple, okay? So nothing complicated at all. Then let's measure the mass of this stone, which is fourth object. Just click on that. Padlock
I
gonna
think
move out.
that's either, okay, I think that's 70 grams.
Yeah, we can read that into 70. Yeah, that's fine. I think let's read into 70. And let's measure then the cylinder. That is the first object. You can
That's,
zoom in actually if you want to see clearly like this one.
yeah. It's between 165 and 170.
It's between 165 and 170. Technically, you can read in between. So if you want to read in between, now each of that small line represent 5 gram. In between means 2.5 gram, right?
Right, yeah.
So you can read this into 170, 165, 167.5. Right? So that's totally fine. Yeah, if it is really in between, we can read in between value. That's the estimated value. 167.5. Okay, so we have all the mass measurement done. Anybody have any question, difficulty?
Yeah, how do we measure the volume? We did the
Yeah,
mass,
that's
right?
we're gonna talk about in a bit. Yeah.
Oh, okay.
Okay, if there's no question on the mass measurement, then we'll continue to the volume measurement. Now, in this experiment, usually, if you want to get the volume of the object, let's say if I have a square shape geometry, like the three-dimensional object, if you want to get the volume, you can multiply length, width, and height together, right? But that can be done only if I have an object with proper geometric shape. That method of measuring dimension not going to work. The object like padlock doesn't have a proper geometry. Object like a stone doesn't have a proper geometry. So measuring dimension not going to work, right? Because of that, what we're going to do in this experiment, we're going to use the method actually explained by the Archimedes. So what he explained, if you have a object, and then if object is submerged into the water container, so let's say I have a cylinder here, and then this is the water level. Let's read this level like Y1. Let's say the number is like maybe like 50 milliliters line, okay? 50 milliliters. Let's assume I have a scale right here attached to this cylinder, and then that scale is milliliters. Now, if I want to measure an object, well, all I have to do, bring that object and then drop it into this water container. Then you can see the water level will rise little bit into the new level. And then I can read that level. Let's say that is Y2. Let's assume that is 70 milliliter line. Then the object volume is actually the amount of water level rise, okay? So which means the Y2 minus Y1 is actually the volume of the object. So in this case, volume of the object is about 20 milliliters. Make sense? Any question? So that method is very useful. The reason I don't need to care about the shape or the dimension of the object at all. I just need the container with the scale attached to that, right? So that's the method we're going to use in the simulator. The one other important thing, the milliliter unit is actually not SI, okay? This is not the SI unit. So we need the SI unit. The conversion from the milliliter to centimeter is each 1 milliliter is equal 1 centimeter cube. Okay, this is our SI unit. Because of that, in the simulator, we're going to read in milliliters. However, the conversion is direct. Technically, this value I can just write directly 20 cubic centimeters. So we already have the conversion in terms of directly there. We don't need to do any other calculation to get the SI units. Okay.
Wait,
All right.
Professor,
Any question?
you said 1 millimeter is equal to 1 centimeter?
1 centimeter cube. This is volume. 1 centimeter cube. Okay. Because your volume is always length times the width times the height. So
Oh.
which means you're multiplying 3 centimeters together, right? Length in centimeter, width in centimeter, height in centimeter. So the volume should be always with the cube.
Oh, okay.
Okay, any other question? All right, then to get the volume measurement in your simulator, if you look at the left-hand side of the simulator, you will see a couple of different options. Then on the very top, second one, it says find mass. So click on that. Then you have another option there, find volume. Just click on that. As soon as you click on the volume, find volume, then you will see simulator change into a beaker, cylindrical beaker, which has the water like maybe half filled. And then the level of the water you can see in this right-hand side zoom in picture. So now if I want to drop something and then find the volume of that, I should know the starting point, right? Y1, and then I should know the ending point Y2, right? That Y1 is the starting level right here on the zoom in picture already showing you. So we just need to read that level first, right? Then again, you can take a look the scale here to identify what are the smallest reading, right? In that scale goes from 20, 40, and then so on. But in between, you can see a couple of other lines. So this is 20, this is 25, 30, 35, 40. So which means each small line is about like 5 milliliters, like our spring balance earlier, okay? Spring scale earlier. Any question?
Yes. What's the starting point
Right here, this line, this is the water line.
and the
So
end
this
point?
endpoint, to get the endpoint, you have to put the object in first. Okay. So this is the
Oh, okay.
starting point. So you read that first. This is about 50, okay, 50 milliliters. Now, if you want to find anything, volume of any object, you click the object, then object goes into the water container. Now you can see water level rise. Now this is actually ending point. We have to remember the starting point, okay? It's 50.
Right, okay.
And now you read this number, this level, and then subtract the previous level. Then you will get the volume of the object. Okay, any question?
Thank you.
Okay, right now this is about 60, 65, 70, 75, right? So we started at 50, 75 minus 50. So our volume of the padlock is about 25 milliliters, but you know the conversion is directly to the cubic centimeter, so I can just type that directly here, 25. Good, any question? Okay, then let's continue. Then I want to measure a stone. You can just click on the stone, then the padlock is gonna come out, the stone goes in. Starting level of the water in the simulator always the same level, okay? It's not gonna change. So now it is again 60, 70, 75 minus 50. It's still about, in terms of volume, same, right? 25 cubic centimeters. And then I need the cylinder. That's the first object. If you click on that, stone will come out, cylinder goes in, new level is at 70, 70 minus 50 is about 20 cubic centimeters. And also, I think I forgot to mention that in case if you still have trouble with the Microsoft Excel and the Office, you can download those that package directly. Just Google it, CUNY Office 365. Just search on the Google, then this page will show up. Just click on there, and then you can download the Office whole package free of charge. Click login into the Office 365. And that will ask you actually the CUNY username and password. Okay, your CUNY first username and password. You put that in, then you will go into this page. Okay, you can see all the Office programs you can actually get free of charge. Okay, Word, Excel, PowerPoint, and then all of them. And don't use the browser version. If you click on here, this is the browser version. Okay, it will run on the web browser. A problem will that there are some option, like for example, last lab I were talking about equation editor, but equation editor you can't directly see on here. So that will be a problem. Because of that, what you have to do, download this. If you go into the front page, right hand side, very top, you will see install Office. Just click on that. That will install the whole Office package into your laptop. Okay. So then you can see all the functions which I exactly using in my side. Okay. So that take care of that. Otherwise, all the time you will see some function when I showing is very difficult on your side. That may be one reason. Okay. Any question?
Professor, I wanted to ask, this session is being recorded, right? Because my Excel, there's been something wrong with my computer. My Excel is not opening up.
Okay. Yeah. The
Professor, my
recorded
Excel is
always.
not working either.
You have a downloaded version or the online version?
The online version?
Yeah, don't use the online version. Download this into your computer, okay? You can install the whole package. All you have to do, click here, click this down arrow right here, install Office 365.
Okay.
Yeah, so that's the best way, I think. It's okay to use the online version, but this is free, nothing to pay or anything, just download it. Okay, any other question? All right, then let's continue. Now, in terms of measuring, actually, we done everything. So we need actually always, as we proceed, we're going to like to collect the picture of the apparatus. So we'll collect 2 pictures of these 2 apparatus. The easiest way to do it in our simulator is to take the screenshot, okay? You can take the screenshot if you have a Windows machine, Windows button plus the print screen button. That will do the screenshot. And there are many other ways to take the screenshot. Okay, it doesn't matter how you take it. And even there's an inbuilt function inside the Excel. If you go into insert, you can see, you can take the screenshot from there too, okay? And the screen clipping tool is already included in there. So you can take the screen, whatever the screenshot you need, just select that area. And that will do the screenshot for us automatically. See that? That
Just
will appear
screenshot any of the
automatically
simulation?
on your page. Go ahead.
Sorry, screenshot any of the simulations?
No, you need the both of them separately. So you need the volume measurement and
Okay,
also
and then the
we
mass.
need the mass measurement. Yeah.
Okay.
Doesn't matter which object is there. We need only one of them. Okay. Just put one object. Doesn't matter which object is, but we need only one picture.
Okay.
Yeah, if you do this Excel screen is that is sniffing tool, that actually easier, the picture automatically appear on the Excel page. All you have to do when you go into insert on the very top menu bar, then there's illustration, the second icon, or you can see the picture here. And then right to that, you will see the screenshot. Just click on that. Then there's a screen clipping. If you click on that, it will ask you where you need to clip there, like this positive sign now. All you have to do, click wherever you want and then drag. Keep the click left hand side and then drag from the right hand side. Then you can select the area. We interested only that part, right? Where our simulator is. Then release the hand. Then that picture automatically come to your Excel page. Okay, there's various way to do this. Doesn't matter how you do it. But if you don't know it, you can try this way. Okay, that is easier.
Professor,
Yeah.
the downloaded Excel version I have, I don't have that question 1 that you have on under. Did you change it? Because I just downloaded it. Ooh, you're killing me. This happened.
Not
week too.
probably not just. You probably download half an hour ago, maybe. These
Yes.
questions are not there.
No, you're killing me with this, man. Like, don't post them if you're gonna change
It's
them,
it's
please.
not big deal. I will show you where those questions are. Okay, don't worry
Yeah,
about it.
do you
Don't need to
mind if I just
re-download.
type it?
Yeah. I will
I'll
show you
type
where the questions.
Q1 and then I'll type in the answer. I'm just not gonna type out the question. Is that cool with you?
No, I will show you where the question are. All those questions are here. If you scroll down your lab manual to page number 4, these are those 4. Okay, all you need to do is, if those are not there, just copy from here.
Okay, I will.
That
You know, I'm just
question.
gonna download it like right before your class starts. I'm gonna just start doing that. Thank you.
Okay, so if you highlight it and then right click and then go to your Excel sheet and then paste it. That's it. It's not big deal. Okay. All right. So any other question?
So we have to paste it and then we have to answer the question underneath, or we're just copying and pasting it?
No, answers you have to write. I will tell you the answers in a bit. Okay. We'll talk
Okay,
about that.
and for the screenshots, we have to put both of those in that box.
Yeah, that's it. Yeah.
Okay, so
So it says place your screenshot of the simulator. So we need 1 per each. Okay. All right. So then let's do the calculation. We almost, like, in terms of simulator point of view, we almost done. We just need to do the calculation. So let's do experimental density calculation on column E. So you know density is mass or volume, right? So all I have to do, density is mass or volume. I need to do that calculation on Excel. Excel always, any calculation start with the equal sign and the mass, C number 11, divide by volume, D number 11. That's it. That will do the calculation for you automatically. Okay. C number 11.
I'm sorry,
over
how
D
did
number
you do
11.
that?
Let me type that here. This is density. Density calculation for lock. So that's the command, equal sign, and then after that, okay. C11 over D11. And the rest is also the same. You can just retype the same command. Next one is C12 over D12. Following one is C13 over D13. But in Excel, you can do this too. If you doing the same calculation by using the same 2 column downward direction, you go into the calculation you just done and you click on there. Then you will see that cell is highlighted with the green line around it. And on your right hand side bottom corner, you should see a small green dot. Bring the cursor on top of that. Cursor sign should change into like positive sign. Okay. Then you click from your left hand finger on the touchpad and then drag from the right hand finger on the touchpad. Then that green line you can see slowly moving downward. And then let it go. Then it will do the calculation automatically.
Excuse me, Professor.
Yeah.
I'm confused on how you got 8.8 and how you did all of how you got to that answer and what you clicked and everything.
This one you have to just do C11 over D11. This number 220 divided by 25. Mass or
So
volume.
20 divided by 25.
Yeah, but don't
Okay.
write the numbers. Okay, in Excel we don't usually do it. If you want to do any calculation, don't type the 220 equal sign. Just we're gonna click on the cell where that number is. C11, okay? Divide by, volume is right here, just click on that, D11. Then you hit enter.
Okay.
Nothing wrong, type in the numbers, but in the Excel, easiest way is actually use the cell name, okay? And the next one is the same density for the stone. That's gonna be then C12 over D12. And the next one is also the same. There's no difference. Cylinder. That's gonna be equal sine C13 over D13. This should be C13. Okay, here. Okay, then you type those commands that will do the calculation for you. Okay, any question?
How did you do what you just highlighted? Because I just tried doing it and it like deleted everything.
This one or right here?
No, the highlighted part, the density lock, the density
This
stone,
one?
density stone. Yeah, I just tried doing that and it completely deleted everything.
If you want to highlight, you just select the area and then click here. You don't need to necessarily highlight anything. You can just type the command right here. That's good enough. The function we're using for each of this calculation, I just collecting that function. Okay.
Professor.
Yeah.
How did you do the place the screenshot of the stimulation? Could you show that one more time?
Yeah. So all you have to do, go click insert on the very top panel, menu bar, and then you
Okay.
should see pictures. And then little bit to the right, you should see a screenshot. Then if you click on that screenshot, just below here, you should see screen clipping. Just click on
Okay,
that.
I have to save the picture first.
You go to insert, pictures, go to little bit right, click on the screenshot. After you click the screenshot, click on the screen clipping. Then you go and select wherever, highlight wherever you want the screenshot, okay? Then that should appear on your Excel page. That's it. Okay, any other question? All right, then now, since we already know the density values, now one of the advantage of the density is actually same for the material. We can identify which material these objects are made of. That's what we're going to do next, okay? Now to do that, what you have to do, if you scroll all the way to page number 4 on your lab manual, you will see a data table. So that table shows you the known values of densities, different elements, different materials, okay? Now we can compare the numbers we got to the table. So the first object padlock has the number 8.8 gram per cubic centimeter. Same unit given in your data table on page 4. You have to find that number 8.8, okay? If you search through, you will see you can't find 8.8 exactly, but you can find the number very close to that, okay? So we will read the number very close to that. That's the plan, okay? Question.
So like for the lock, it could
Mhm.
probably be maybe something like copper, like the 8.96.
Yeah, exactly. Yeah,
That's like the closest to it.
yeah, that's the closest. And then usually, like if you do a chemistry or physics class, this kind of items, we can take a look like other information. For example, the padlock, you see that is a yellow color metal object, right? So that color is matched with the copper. Copper is like yellowish color. So like extra other information we can actually use to exactly identify if we have the two closest numbers. Okay. Yeah, this is exactly the copper. So let's input that information. So which means the material should be then copper. And then the number we get from the 8.96, right? That's that we call the standard or the known value. Now in the experiment number 1, we discuss about like 2 different type of error calculation, if you remember, right? So we talk about percentage error if I have a known value, and then if I calculate the same in my experiment, we would like to compare them. So what we do, we take the difference between known and the experiment, absolute value divide by the known, and then we'll multiply this everything by 100. So that is called the percentage error calculation, right? So we can do that error calculation for this one to compare these two numbers, okay? These two numbers. We expecting 8.96 if the lock is exactly pure copper, but lock may be not the pure copper, it may be an alloy, or maybe we done something little bit wrong in our measurement. So that's why we see a little bit of difference there. Okay. Let's do that function here, equal sign. This vertical sign represent only I need the positive number, right? So I take in the different, but I need the positive that we call the absolute, right? ABS command, open brackets in Excel. Then the cell number F11 for the standard or the known minus cell number E11 for the calculated, divide by the cell number F11 multiplied by 100. That will do the comparison. Usually that
Wait, I'm
percentage error
confused.
should be, yeah, go ahead.
Why did you multiply it by 100?
Because it's a percentage. If you don't have that 100, this is a comparison, right? So you will get a very small decimal number like that. So we multiplying by 100 to say per percentage how much is the difference is. So the number still should be very small even after multiplying by 100. Okay.
Wait, so Professor, what's the point between experiment density and known density?
Known density is actually what we're trying to do in this experiment, out trying to identify what is the material this padlock made of. Otherwise, you have object, you don't know what it is. Even you calculate, we're not sure what it is. That's why we need to go to the table and then take a look known value. Then only we can confirm the material of the object made of. That's the idea. That's what you actually do in here. You have a calculated value. You go to the table and then take a look what numbers are known. Then you compare those two to identify how much closer those two numbers, so how much different. If you have a very smaller percentage error, in this case, we are getting like 1.7. So that's a very small number. So these two numbers are very close to each other. So we have a very good idea of what's the material this padlock is made of. That's what the experimental objective, what we're working on. Question.
I'm sorry, can you just do it one more time how you got the percent error?
Let me copy that command into
'Cause
here.
It was cutting out, that's why I got lost. Okay, thanks.
This is the command after equal sign, everything, okay? Right here. From the equal sign and the rest. Equal sign ABS F11 minus E11 divided by F11 times the 100. Okay, any question?
I'm still stuck on the part that you got experiment density. I don't know why it's not working for me. I'm not getting that number.
220 divided by 25.
Yeah, but like, you know how you put it on Excel and it did the calculation for you? I don't know how to do that.
You have to write exactly this way: equal sign, uppercase C number 11 divide by uppercase D number 11. Those
Professor,
are
can you
right here.
read
Okay.
it because I still don't understand it either.
Say it again. Say it again, your question.
Can you just read, can you show it again? Because I'm still confused on how you did all of that.
Right here, this is the command.
Yeah, I'm confused as well.
Equal sign, C number 11
No, I
divide by D
understand.
number 11.
I'm just confused on the percentile, the next part that you did, like with the AB. Yeah, I'm confused on that. Like, how did you get F11? Where'd you get F11 from? Like, what did
You
you?
have to take a look where your numbers are. You are comparing these two numbers, right? You are comparing these two numbers. So which means in Excel, we don't usually write the number. Instead of we actually read the number where the cell value is. How you read the cell value? This way, like if you have, let's say, I have a graph sheet. This is my graph sheet, right? If you want to identify any point on the graph sheet, you read vertically where that is, and then you read horizontally where that point is. So that is actually we call the cell number. You take a look the very top line, which has letters A, B, C, D, and then so on. That's going to be your vertical name of the cell, okay? Horizontally, you go all the way to the corner of your left-hand side. There are numbers, 1, 2, 3, 4, and then so on. You read what number horizontally this cell is. Then you have a cell name. Cell name is wherever in vertically, a letter, wherever it in horizontally in this line, that should be generally a number. So that's what we actually do in here, okay? Now, if I want to do this calculation by using the cell names, all I have to do, I need to calculate the density, which means the log mass divided by the log volume. So you can see log mass is on this cell, right? You go all the way up, that is on the C column. And then you go all the way to the left side, then you read this number, that is the row number. So the cell name of this cell is actually C number 11. That's why we're writing here, okay? Instead of, you don't need to read always. You put the equal sign on the cell, like this one, equal sign wherever you want to do the calculation. Then you bring your cursor where the number is, mass of the log, then you click on there. Then that C11 automatically will appear. You don't need to do anything. Then divide by, then you click your cursor again to the volume of the log, then you click again. Then the D11 will actually automatically appear on there. Then you hit enter button. Then the calculation will be done automatically for you. Question. If you can't do that, then only other option is you can use a calculator and then do the calculation, put the numbers here, okay? But that is not the purpose of using the Excel, okay? So that may be the only other option if you can't really figure that out at all. Any question? Then let's do the percent error again, equal sign. Always everything must start with the equal sign, okay? That ABS represent the absolute value, okay? All the command usually I copy paste. You can see every command start from equal sign and then afterward, okay? All of these are then commands to particular calculation, okay? This should start with the ABS, which means I'm considering only positive sign, open brackets, I'm comparing two numbers. First number should be the density known for the log minus second number for the density we calculated for the log, close brackets, divide by density known value for the log, multiply by 100.
Professor, isn't the known density
Known is
for the copper? I'm confused. They're both not 8.8.
Oh yeah. So I think I did
8.96.
that should be 8.96. This one. Okay, yeah.
Professor, can you repeat
Yeah.
how you got I got the density for experiment, but I don't know how to get density for known.
That you have to read from the table right here.
Oh,
So
okay.
you need to find which one gonna be closest to the 8.8.
Oh,
Right? Yeah, since we don't have the 8.8 anywhere on the table, so you need to find which one is the closest.
oh,
And then sometime we may need little bit other information. For example, this padlock is, yellow color metal. So that yellow color metal gonna be actually a copper metal. So that kind of information will helpful when we're doing this
mhm.
search. Okay, that's all. Any other question? Okay, then let's do the same for the other two. There's no difference at all. This known, the same equal sign, C number 12 divide by D number 12. That will do the calculation. Then you go to the table, search that number, 2.8. Now that number is tricky because if you search that, you're not gonna see 2.8 anywhere. You will see 2.75 here. For the talc, you will see calcite 2.72, but you will see feldspar has the upper limit of 2.76. So that is the closest, okay? So we're going to read the closest. So I can read this one, 2.76, upper limit, 2.76, closest to the feldspar. Okay, question. Then again, the same error calculation. Sorry, this should be 2.76. This should be error calculation. Okay, let me do that also. Any question? Okay, function is same again, ABS, open brackets, density known for the feldspar stone minus, we calculated right now, E12 divided by F12 multiplied by 100. So it's still very small number. So which means our stone should be probably the feldspar, okay?
How many significant figures do you have on yours? Because I think mine's a bit higher, so I can change them. And can you go
So
over?
usually this one, since we do a division for the density, you can see each has right here 2 sig figs. So you can keep the 2 sig fig for all of these numbers. So you know how you can change the 2 sig fig by using this top part right here. If you change that into general to the numbers, and then you can click this right and left arrow to reduce the amount of significant figures. Okay, we can keep like 2 for all of those numbers. Or you can do the right click too. If you highlight, right click, then the format cells and the number, and then change the decimal places here, okay, into 1. Then that should take care of that problem. Any other problem? That's all. Then we have one more to go, right? So let's try to get identify the cylinder. Cylinder, we already have the calculated density, right?
Professor,
Let's compare that. Yeah, what's up?
You didn't finish writing the formula for the, what is it? G13 to get that?
Right here. let me copy paste that. This is the PE for the stone. Okay. Yep. So equal sign and then rest. Okay, then let's take a look the 8.4 on your table. Okay. Take a look the table. Where's the 8.4? You will not see that also absolutely perfect number, but the closest one. If you look
Oh wait,
at the
you're looking
closest,
for, Professor, you're looking for 8.4, right?
yeah,
Oh, so that would be brace?
yeah, that should be brass right here.
Oh,
Okay,
okay, yeah.
So then we can pick that, right? That should be the closest, and the number is not 8.4, but that's fine.
8.2.
8.5, right?
Oh,
8.5. Okay.
okay.
That's all. Then you compare those two numbers. Let's write that command equal ABS, open brackets, expected or known value should be 8.5, F13 minus our calculated value E13, close brackets, divide F13, and then multiply by 100. 1.5 is still very, very low percentage error, which means our calculated values are actually very close to the expected. Okay. So this is going to be then PE for the cylinder. That's the function I use. Okay. You don't need to highlight any of these, but the copy paste the command, because that will be useful as you continue in the class. It will help you to really understand and then gain the knowledge how to use those functions, how those functions look like, things like that. Okay, that's going to be extra skill you're going to be gaining doing this in the Excel. That's why I mentioned don't try to use the calculator, instead try to do this way. That actually going to be good for you guys. Okay. All right, any question?
Yeah, Professor, how do you get the significant figures again to the correct place? I'm trying to do it, but I can't.
Yeah, first you need to highlight this area. If you want to highlight, click middle of the cell, okay? Not the corner, middle of the cell, and then drag. Then it will highlight.
Okay.
Then you can go to the top menu bar right here, which says number in the middle of that. You see that number term? If you don't see the number term, then click on the down arrow here.
Oh, okay, I got it.
Select the
I got
number.
it. Thank you.
Yep.
Thank you.
Yep. Any other question? Okay, then we're almost done. So only very few one thing to do. The cylinder, you can see now the lock and stone doesn't have a proper geometry. However, cylinder does have the proper geometry. Okay, cylinder is actually, we can calculate the volume of the cylinder another way, because it has a circular geometry on the top and bottom, which means the cross-section area is pi, radius to the power 2. And then it has a height, right? H. So the cylinder volume generally base times the height. The base is actually pi r squared. Pi r squared times the height. So the cylinder volume is base A times the height. And in this case, you can see if you go to the table, actually the diameter is given, but the radius is not given, right? Even though I would like to have the radius is not given, right? So which mean, let me write that again. I think my screenwriting moved when I moved the cursor earlier. So if I have the base A, that should be pi times radius to the power 2, but the numbers given only for diameter. So the radius is actually diameter divided by 2, which means the cross-section area is pi r to the d to the power 2 divided by 4. And then the height is h. So the volume of the cylinder is cross-section area times the height. Cross-section area is pi d square divided by 4 times the height h. So technically the cylinder, I can actually do that calculation by measuring the dimension, right? We can't do it for stone and the padlock, but the cylinder we can, right? Because of that, for cylinder only, we can actually do the volume calculation that way. You can see for cylinder method 2 on the table tells the diameter and the height. So let's calculate the volume by using our equation, okay? That's the plan. Any question? Okay, since we know the formula, we just need to write it down. Equal sign. Pi is pi, open and close bracket, because pi has a lot of decimal places. If you do that command, it's going to read all the decimal places, okay? Otherwise, the number is close to 3.414. Multiply by diameter is cell C number 15. Power is actually shift number 6. That hat is the power sign for the Excel. Number 2. Multiply by the height. Divide by 4. Let me copy paste that command also here. This is the volume for the cylinder, okay, with the dimension. Okay, question.
Can you repeat that? I'm sorry.
Function is right here. Can you see the function? Pi, uppercase, open close bracket, multiply by C15 hat number 2, multiply by E15, divide by number 4. Write it exactly as it is, okay? Uppercase letters should be like that and everything. If
That's
anything.
PI, right? Not P1.
No, PI that.
PI, okay.
Mhm.
And with the two significant figures, we should be getting 20 for that answer, right?
This one, yeah, we can cut down that into 2.
I figured you wanted like everything in the in the chart to be the same significant figures.
Yep.
Okay, thank you so much.
You can keep like 1 or 2 significant figure higher in that one, because this is a middle calculation, not the density at the end. So we'll round the density value if needed, okay? So usually when you do the calculation in the middle, you don't need to round anything. Don't need to worry about rounding, but at the very end, we will round. Okay, any other question?
No,
Okay.
class over.
Say it again. Okay, then that's it. Then we'll calculate the density of that equal sign. Mass of the cylinder we already measured earlier, 167.5. C13 divided by the volume, we're going to use the new value, okay? F15, because now we're working on method 2. Hit enter. Now you can see the new density, which is almost very close to the previous answer, but slightly different. So this is the density of the cylinder, method 2.
So
By
to get the
using-
density of the cylinder, you divided 167, which is the mass, by 19.77, which is a value.
Which is the new volume. Yeah, that's
Okay.
correct. That number you can round it to exactly 2 sig figs.
Mm.
If I round it to exactly 2 sig fig, you can see it look like perfectly match with the
Right.
known value, right? But it
Mm.
still will do the percentage different calculation. The reason in this Excel cell, even if I round the value to 8.5, all the other decimal places are there. It will read automatically if I use the cell name, okay? Equal sign, ABS, open brackets, known value 8.4 minus 8.5 minus F13, and then new cell G15 divide by F13 multiplied by 100. You can see very small number there. Reason, even we round, some of the values is still reading, okay? Some of the decimal places is still reading automatically.
Oh, wait. So for the difference, what did you subtract? I missed the numbers.
I will write it down, that command here. Okay, it's going to be the PE for the cylinder method 2. Okay. Okay, so that's the command function we use for that. Okay.
Mm-hmm.
All right. So we almost done. So only thing we need to do is just to discuss a little bit last few questions. Then you can write the answers for them before you upload the Excel sheet. Okay, I will give you the answers in words, but you have to write it down 1 or 2 sentences yourself. Okay, any question? Okay, then let's take a look what kind of answers we expecting for these 4 questions. First one asking which of the densities you determine to be expected the least accurate, that means which has the highest error, right? To understand that, all you have to do is check the percentage error. You can see all 3 different objects. I have the percentage error here. Whatever has the highest percentage error gonna be the least accurate answer, right? So you just need to write like 2 sentences. How you pick the answer and then what is the answer, okay? Make sense? Type your answer on this space. And the next question asking, would the density change if the temperature happens? Actually, density is mass over volume. Mass does not sensitive to the temperature. That does not change at all. However, volume of the object is actually sensitive to the temperature. So if you change the temperature, then the volume of the object changes, which means automatically the density must change, okay? So you just write again like 2 sentences. If 2 sentences is good enough. Why the answer is change? The reason is volume is actually function of temperature, or volume is sensitive to the temperature, okay? Either one is fine. Any question?
Professor, so for the first question, you said we write down, so like for example, it will be copper 1.79%.
Which has the highest percentage error is the least accurate number, correct?
So that's the copper 1. Okay, thank you.
Yeah, just write like what is the answer, why the answer, you pick that, okay? Like 2 sentences. Make sense?
Yeah.
Okay, and the second one, answer is yes, the density will change. The reason, volume will change if the temperature change happen. Okay, again like 2, or you can write more sentences, doesn't matter, but at least 2 sentences. Okay, what's the answer? Why you pick that answer? What is the reason? And then the number 3, in terms of metal cylinder, we are measuring the volume in 2 different methods, right? Which density do you think was more accurate? The one obtained through the water displacement, because we measuring it 2 different ways. One through the water displacement, or one through the dimensions. Again, to get the answer, we can take a look. What is our percentage error? Which one has the lowest should be more accurate, okay? Take a look the percentage error and then stick to that. Which one has the lowest, that's going to be the most accurate answer, okay?
Oh, so the one with that was measured by dimensions was...
Dimension method in this case has the low PE, correct.
Mhm.
Professor, for method 2, it says percent difference, not percent error.
Now this change that into also percent error. Because we done the percent error, okay? We compare that number to the standard value. Every time we have a standard, we should do percent error, okay? Yeah, that's a good point. And again, the last question, what is the benefit, if any, measuring volume by Archimedes? This method, the volume or that water displacement method or the beaker method is actually the Archimedes principle. So why that is useful? I mentioned that earlier, the reason, like the stone, for example, or the padlock, if you take the stone, doesn't have a proper geometry. Technically, you can't measure dimension at all. If you take the padlock, I can't measure the dimension, right? So such objects, dimension method not going to work. Only method going to work is actually the Archimedes observation method. So just write again 1 or 2 sentences. Or if the object doesn't have a proper geometry, then there's only one way to measure the volume. That is actually the Archimedes method or the water displacement method. Okay, that's all. Any other question, you can stay on the call. I mean, officially we can stop here. There's nothing else to do on this lab. But if you have any question, stay, I can answer accordingly, okay?
Can you re-explain question 4?
Sure.